Hmm. So yeah, let us start. Welcome to my session. The session is all about Cohen Sutherland line clipping algorithm, and we shall see how exactly this works. So here is the code. I'll come back to the mathematics for this, and if I run this, and this is what you get. So basically this is the input and this is the output. So you can see here there is a clipping rectangle, there is a line, and this is the zoomed version of this. This is the output, this is the clipping rectangle, and whichever pixel comes in between the rectangle I should highlight. Whichever pixel doesn't come, I should not highlight, I should not show. So we'll see how exactly we can do this in a minute. Is there any problem?
No, sir.
I don't know, someone is muting me. Did you hear all my words till now?
Yes, sir. I guess when non-BMSIT members try to log in, you wouldn't. You would get less voice.
Okay, because yeah, it's not less voice; it's like completely mute. Anyway.
Okay, but we are able to hear completely.
Great then, great. So yeah, if you run this program, this is what you will see, and this is my input, and this is my output. So whichever pixel comes outside my clipping rectangle should not be shown, and whichever pixel comes within the rectangle should be shown. And yeah, this is the zoomed version of my output. So why exactly I have zoomed this, you will understand this in a bit. All right. So this particular theory, let us understand the theory behind Cohen Sutherland clipping algorithm. So the agenda for today is we'll start module 3, and module 3 is all about clipping, 3D transformations, illumination models. So now let us start the first one called clipping. Basically, what do you mean by clipping is, for example, if you take your mobile phone, or if you take your camera, whoever comes in between or within the camera frame, those objects would be visible to the customer, and those guys, those objects, those pixels which comes outside the clipping rectangle will not be shown to the customer. So that is what is called as clipping. I request everyone to mute themselves. So this is the theory behind clipping, and there are various forms of clipping, various types of clipping. Let's start with point clipping. There's something called as line clipping. There's something called as polygon clipping. So Cohen Sutherland algorithm talks about line clipping. And there is another algorithm called Sutherland-Hodgman algorithm, which talks about polygon clipping. So I'll repeat, clipping means just take out whatever pixel comes outside the clipping rectangle. Whichever pixel comes inside the clipping rectangle should be shown to the customer. Mr. Hemant, can you please mute, man?
Sir, it is not mine, sir. Apparently.
Someone else, yes. So yeah, let us start with clipping. There are various types: point clipping, line clipping, polygon clipping, etc. Cohen Sutherland algorithm talks about line clipping. So all we have to do is there will be a rectangular window that is also called as clipping window. There will be an object, example line, because we are talking about Cohen Sutherland. Cohen Sutherland talks about line clipping. So we have a rectangular window, we have a line, and we have to show only those pixels which are inside this rectangle. And those pixels which are outside this rectangle should not be shown. It means to say it should be clipped off. So, example, let us take this particular rectangle, and let's say I have a line like this. So what I essentially need to do is take these parts and also take these parts, clip off, means remove these. And what I need to show is the pixels which are coming inside the rectangle like this. So how do we do this? There are various ways, but Cohen Sutherland algorithm talks about doing this task in this way. So there are various combination of lines. For example, a line can be AB line. A line is as a line which is completely inside the clipping rectangle. There can be a line like EF, the line which is completely outside the rectangle. There might be a line called GH, wherein some parts are outside and some parts are inside. There will be a point, there can be a line called CD, same story, some parts inside, some parts outside. How do we clip this? Well, what we can do is let's fix some boundaries so that we can know what to be clipped. For example, if this is your window, and there you can just have this x-axis boundaries and y-axis boundaries like this, and thus you will get 9 regions. We call this as out-code regions, and assign essentially 9 codes. For example, if this is top, and if this is left, and this is bottom, and if this is right, obviously this becomes top left, this becomes top right, and this becomes bottom left, and this becomes bottom right. So this is all pure English, but how do I make my machine understand about what is top, what is left, what is right, and what is bottom? So, well, we have 4 codes, 4-bit codes perhaps. So if I can assign something like this. This is a TBRL code, top, bottom, right, left. Need not to be TBRL. You can take any sequence, but whichever bit you highlight or whichever bit you make it as 1, that indicates that particular region. For example, how do I make my machine understand that the line or the pixel is at the top region? Well, what I'll do is I'll make my top bit as 1 and all the bottom, right, left as 0. So if the pixel is at 1000 means that pixel is at the top. So left means make only the left pixel as 1, make others as 0. Bottom means TBRL, make the bottom part as 1 and make others as 0. Right means TBRL, the third bit is 1 and others are 0. So on the similar lines, can you tell me what is this? This is top right. So TBRL, so T is 1 and R is 1. So B and L, they are 0. So this is how you'll make your machine understand about where exactly your pixel lies. And I can use these 4-bit codes to make my machine understand about this. So next point is, how do I exactly clip the pixels outside the window? Well, what we will do is, let's first calculate the intersection point, then redraw the line from the inner window point to this intersection point. So essentially, to make you understand, for example, I want to take this line CD. So to clip from D dash, that is the intersection point, from D dash to D. Essentially, I should not show this D dash to D. I should only show from C to D, C to D dash. So what I'll do is, I will first calculate the intersection point called as D dash, and then redraw the line from inner window point to this intersection point. Means to say, I'll redraw from C to D dash. So it's indirectly I'm not drawing from D dash to D. So it's just cool. So in order to I'll repeat, in order to line, let's say from G to H, I want to draw a line, and I should clip from G to G dash and H dash to H. So how will I not draw G to G dash and H dash to H is, I will calculate the intersection point G dash and H dash. I will quickly draw a line between G dash to H dash. Thus, indirectly, I'm not drawing these pixels and these pixels. So in that way, it's very cool. So this is what is called as Cohen Sutherland algorithm, and the main question now comes is how to exactly calculate this intersection point. So see this D dash, G dash, and H dash. If you can ask me the question, what about E and F? Well, E is also lying outside, F is also lying outside the clipping rectangle. So no need to draw this E and F. So if you don't draw this EF, obviously it means that it is being clipped out of the clipping rectangle. What about IJ? I is also outside the clipping window. J is also outside the clipping window. So intersection point I dash, J dash, they are also outside the window. So no need to draw. So you need to make the machine understand about where exactly this, first is you need to calculate the intersection point, and then you should make the machine understand about where exactly these points lie. So we'll do that in a while. So the main challenge is to calculate these points. So we'll see how. So what we will do is, first point, we will take a clipping rectangle as usual. What we will do is we will mark the boundaries. So let's say this as XY. These two are x-axis, and this is my y-axis, and this is also my y-axis. So if I can earmark this as, this guy as x-min, and which one? This one, and this as x-max, horizontal wise. And if I make this as my y-min, and this as my y-max, vertical wise. And let's take a line. So I need to essentially clip this part and this part. So I should draw only this from this intersection point to this intersection point. So before we calculate the intersection points, so let us try to understand the existing points, or else the points which we already know. So for example, if this is the scenario, and if I have a clipping rectangle like this, and if I have a line like this, can you now tell me what is this port, what is this point? This is obviously x comma y, but x, I know it as x min, because this particular line is x min. And this particular point is x max. So x I know, but what about y? Can I write y as y min for this point? No. So y min is here, and I want to know what is this y. So I don't know. I cannot write this particular point as y min, because y min is here. So y I don't know here. Same case, y I don't know for this. I cannot write y is equal to y max. Y max is here. X I can write as x max, because this vertical line is x max. I cannot write y as y max, because y max is apparently here. So for this coordinate intersection point, what is y? I don't know. If you take another case, another line, something like this, can you now tell me what is this point and what is this point? Well, y is equal to y min definitely for this point, because this line is y min. But yeah, similarly for this, since this is y max, I can write y is equal to y max. But for this point, what is x? Can I write x as x min? No, because x min is vertical point, vertical line here. So x I don't know here, and similarly x I don't know here as well. So now the real challenge, is calculating those question marks. If you have missed, I'll just repeat. Here is my my clipping rectangle. Here are my boundaries. This is x min, x max, y min, y max. If I take a line, x min is this, x max is this, y I don't know for this. Here also y I don't know. And if I take another line, y is equal to y min, x equal y equal to y max, x I don't know here, and here also there is, I mean I cannot determine x just like that. So my real challenge is calculating those question mark, means to say this y, what is the y here, what is the y here, what is x here, what is x here. So what we do is we know that for a line x naught comma y naught to x end comma y end, the intersection point xy can be calculated something like this. Let's take a rectangle, and this I know this is a line, and I'm saying for a line x naught y naught means this is my x naught y naught, and there is x naught y naught to x end comma y end means this is the x end comma y end.
You are calling is temporarily unavailable.
The intersection point means to say this or perhaps this one. This is x naught y naught, this is x end y end. The intersection point can be this, also can be this. So let us take this. So this intersection point xy, which is my question mark, this can be calculated something like this. So this xy, we have the slope, that is y2 minus y1 by x2 minus x1. So for this point, from this point to this x naught y naught, so the slope is y minus y naught by x minus x naught. So cross multiply m times this is equal to this. So by this, if you, I mean, your intention is to calculate x and y. So take out x from this, you will get x naught plus this times by y, and take out y from this equation, you will get y naught plus m times this. So we should now be applying this formula, that is this x is equal to x naught plus y minus y naught by m, and y is equal to y naught plus m times x minus x naught. So this formula in my question marks. So let's go back where we left with question marks. Let us also keep the formula ready, and now comes, let us now calculate these question marks. So let us start from this y, the left coordinate. So this question mark I don't know. So what you do is you want to calculate y. So apply this formula. Y is equal to y naught plus m times x minus x naught. So that is how I'll get it. Y is equal to y naught plus m times x. X is here, x min minus x naught. So what about this now? Can you tell me? Y is equal to question mark, I don't know. So this will now become y equal to y naught plus m times, what is x here? It is x max minus x naught. So what is left now? We shall calculate this x coordinate and this x coordinate. So now x, apply this formula, x is equal to x naught plus y minus y naught by m. So x equal to x naught plus y. Y means y min minus y naught divided by m. And similarly for this x, the top one, so you can write the same formula, x equal to x naught plus 1 by m into what is y? This is y max minus y. So these are my intersection points. So if I want to put it in a nutshell, finally this is how the final intersection points look like. Let's go back. Guys, are you understanding it?
Yes, sir.
Are you understanding it, guys, or everyone?
Yes, sir.
Great. Great.
Yes, sir.
So should I quickly recap the mathematics? Is it required?
No, sir.
No. Okay. So we'll now go to, I'll quickly show my PDF as well. This is my fifth program, Cohen Sutherland algorithm. And you can see in my PDF, this I have taught you now. What is top, left, bottom, right. And also I have taught you this. And I have taught you this. The same things will now come into your program. You can see all these equations are nothing but calculating intersection points. So this is how my program looks like, and yeah, we'll see all these now. All right, so go back to the code blocks. So I have my program, and if you run for your sake, yeah, let me show the output. So this is my input and this is my output. I have clipped from this point to this point, and from this intersection point to this intersection point. Can you now tell me why exactly I have zoomed this portion and I'm showing this here? The reason is, if I don't do this kind of an activity, the customer will not be, customer in the sense you will not be able to see what is input and what is output. The moment you run the program, you will only see this particular piece. So I just wanted to show what is the input and what is the output. So next question you should get is, why exactly I am zooming this? That is purely my wish. I can say I might as well, written this output next to the input itself, which you could have done it. But I thought, let me show this, in a bigger scale to my students. So that's the reason I am zooming this and showing it at the center of the screen. You need not have to zoom it like this. You can perhaps show the output here itself. Or what you can do is show the input to the customer, have a delay for 2 seconds, and then there itself you can show the output. So it depends on the customer satisfaction. If the customer wants both the input and output to be seen, perhaps you can do something like this. And if he wants the output to be shown, to be shown in a bigger scale, so you can zoom like this and show. So zooming is also, in fact, we have done this in 2D viewing. I have taught you the scaling factors, right? If you can remember, while teaching 2D, 2D transformation, 2D viewing, I had, while derivation, that big derivation, what we did in the class. So scaling factor of X is this, scaling factor of Y, all this we saw there. Anyway, so we'll come to the program now. We'll close this. Okay. So this is the program where it start from the main. So main is, this is nothing but initialize graphic system, and this is single buffering mode, and this is my RGB, red, green, blue. Single buffering mode. Why? Because no animation is required, and I'm not showing any 3D with animation or whatever. It's just 2D static image which gets clipped off. So I should not write, or I need not have to write glut_double. All right. So window size 500 by 500. My window position, initial window position, starts at 0,0. These are all purely my wish. You can purely developers' wish. You're free to change all this. So I have a window which says this heading, and let me call my init. My init is here. So I am having a black window. This one. Yeah, it's starting at 0,0, and I have a black window, and my ortho 2D, my camera coordinates is also 500,500. So my LRBT, which I have taught you in the class, that is also 500,500. So my window size is also 500,500. My camera coordinates, this is LRBT, left is 0, right is 500, B is 0, top is 0. This is my viewing giving the coordinates. This is L comma B. So LRBT, left, right, bottom, top. All right. So now coming to this glut display func of display. So I will go to display function and x0, y0, x1, y1. So x0, y0 is apparently this, the line starting point, and the line's ending point, that is this point, this is 80, 120. So the line starts from 60, 20 to 80, 120. So GL color buffer bit, whatever we had set the color to be black, it will now flush to my screen. And GL color 3F111 means my pixel color is white, meaning to say my primitive pixel color is white. You can see this white rectangle, white line. These are, the courtesy, this line, 115 line. So now let us concentrate on this part. Let us show the input of the customer's input. So begin lines. So vertex 2D, vertex function, GL property, 2 arguments, D is double, x0, y0. So 60, 20 is this, and x1, y1, that is 80, 120 is this line. Let me draw the line first. And then how do I draw this rectangle? Well, it is just nothing but a line loop. Line loop, x min, y min. So x min, y min, x max, y max, these are all my global coordinates. So x min is 50, 50, x min, y min, and x max, y max is 100, 100. Means to say this x min, y min, this whatever we showed here, this one, x min, x max, y min, y max. These whatever I showed now happens to be 50, 50, 100, 100. And xv min, yv min, xv max, yv max. These are my viewport candidates, viewport coordinates. So viewport coordinates in the sense these. So where exactly I'm viewing it. So these are my 200, 200, and 300, 300. I'll come back to that in a moment. So where, yeah, we are done with this. So we are done with the input line and the input clipping rectangle. And next is, it is our job to call Cohen Sutherland by passing the rectangle, clipping rectangle. Sorry, the line that needs to be clipped, that is x0, y0, x1, y. So go to Cohen Sutherland. So you are passing x0, y0, x1, y1. Actual parameters will now be collected into my formal parameters. Same parameters, same arguments are given, same variable names. All right. So you remember this? We talked about regions. LR, top left, bottom right, top, bottom, right, left, whatever sequence you prefer. So we should be carefully talking about our plan about how exactly a pixel situates in any of these regions. So we call those as outcode regions. So we definitely have two outcode regions. One is outcode 0 and outcode 1. Means this particular pixel, and we can name it as outcode 0, and this is outcode 1. And the final one, the one which will allow us to decide where exactly this outcode 0 is situated, that will be pasted in, that will be held in a new variable called outcode out. We'll come back to that in a bit. So I have a Boolean variable, accept and done. So if I say accept is equal to false, means if you take this particular portion, yeah. So accept equal to false means the pixel number E is also outside, pixel number F is also outside. So both the guys I should reject it. Accept is equal to false. So if you can take A, B, both the guys are falling inside the rectangle. So except should be true. And there is done. Done is equal to false means right now the done variable is false, means we have not yet started our algorithm. The moment we make done as true, that means we are done with the algorithm. You will understand that in a bit. So outcode 0, that is the first points, that is x0, y0, outcode region. So outcode region means if you take the points, the line CD, C is inside, D is outside. So C is inside, I can understand. D is outside this rectangle, a human being like me can understand. But how do I make the machine understand? I should be making my machine understand about this. I'll assign the outcode regions, the 4-bit codes. So something like this. So outcode 0, that is calculating the region of first point. You call this function outcode 0 of x0, y0. So go to this function, compute outcode of x0, y0. That is apparently this, compute outcode x0, y0. So where exactly your point lies. So initially make your code as 0, the initial code variable. 0, understand 0 means here. This is 0 means everything is inside. So let me assume that everything is inside. So once I assume it, then I'll calculate the exact point, exact region. So if y, what is y now? You're sending x0, y0. So y is apparently y0 now. If y0 greater than y max. So what is your y0? So I am passing from Cohen Sutherland. So from Cohen Sutherland, I am calling compute outcode x0, y0. So x0, y0 is your 50, 50. So the same things x and y is also, in this case, it is 50, 50. So what is y? Y is 50 now. 50 greater than y max. What is y max? 100. So is 50 greater than 100? No. 50 is not greater than 100. Else is 50 less than, what is y-min? Y-min is 50. Is 50 less than 50? No, 50 is not less than 50. 50 is equal to 50. So the control doesn't go here. Next one. What is x? X is 50. 50 greater than, what is x max? X max happens to be 100. Is 50 greater than 100? No, the control doesn't go here. So next one, else it checks, is x 50 less than, what is x min? X min is 50. So 50 is less than 50. No, 50 is equal to 50. So control does not go here. Control didn't go here, control didn't go here, it didn't go here, it didn't go here. You can ask me why, or what is the logic behind this. A return code means to say x0, y0 is this point, the x0, y0. A return code means it is 50. So return code. So code will now be returned as code equal to. So just to cross check again. So you're passing x0, y0. Where are my x0, y0? Oh dear Lord, it is 60, 20 guys. Sorry. It is 60, 20. I'm so sorry. This is 60. This is 20. Y. It is 60. Sorry, y is 20. X. It is 60. My mistake. All right. So now let us, x0, y0 is 60, 20. Now I'll pass 60, 20 here. All right. So 60, 20 will be passed. Why 20 greater than 100? No. 20 less than 50? Yes. The control will now go inside this. So 20 less than 50. Y is 20. Y min is 50. So 20 less than 50 means yes, control will now go inside this. Now this is fine. Mathematics is fine. But I would like to let you know from the logic angle as well. Why exactly control went here? The logic behind that is, see, where is x naught, y naught is here. It is where? Bottom, left, or top, or right? It is at the bottom. We human beings, we know that this is at the bottom. But how exactly I can make my machine understand? This is how I can make my machine understand. So basically you have all this and check your outcode regions. So in these 4 loops, the control will go inside. One loop will satisfy. So 20 less than 50, code or is equal to code or bottom. So code will now become, so this is equal to code or bottom, which will now be, what is code? Initial 0000, or what is bottom? 4. So 4 in the sense 0100, which if you OR these two, you will get 0100. So this is my latest code now. Code is equal to code or bottom 0000 or 0100. So this is 0100. So what is understanding? So if I send 60, 20, I know that this is at the bottom, and I made my machine understand something like this. So code is now 0100 means that is nothing but, what is 0100? It is 4. But what is 4? 4 is bottom. So we understood that this particular point is at bottom. So let us also, yeah, if I go with this, the control doesn't even, the control after this, it will go here, because this is, and this is just if, this is not else if. Had I written here else, control wouldn't have gone inside any of this. So don't write else for this. I should check my y, I'm done with my x. I should be now checking for x. So what is x? X is 60. 60 greater than 100? No. Else is 60 less than 50? No. So it doesn't go here. Return code. So what is the code now? So the calculated code is 4. So I'll return 4. So what is the meaning? The meaning is x naught, y naught. That is x naught, y naught is lying bottom. So why bottom? Because 4 is bottom. Now, so outcode 0, because this guy will now return, it will now return 4, and 4 will be now placed in this outcode 0. Similarly, we'll calculate outcode 1. You will now understand if you have any doubts here. x1, y1. What is x1, y1? Let us not make that mistake. 80, 120. So 80, 120. Can you now tell me what exactly this function will now return? Outcode 1. So 80, 120 is here. It is where? At the top. So top meaning to say 8. So that is what this function should return. Let us see whether it returns. So x1, y1 is 80, 120. So this is 80. This is 120 now. All right. So code is 0. Is y. Y is 120. 120 greater than y max is 100. Yes. 120 greater than 100. Yes. Code will now become code equal to code or top, which is equal, what is code? It is 0. So it is 0000 or with top. What is top? top is 8. So 8 is 1,000,000. So which is, if you OR 0 with 8, you will get 1,000,000, which is nothing but 8, which is nothing but top. So 8 means it is top. Yeah, common sense. 80, 120, this is situated at top region. For example, if I take a horizontal line, something like this, so you will understand that this is at the left portion and this is at the right portion. So since we have taken a vertical line, so we understood that the x0, y0 is at the bottom, x1, y1 is at the top. So we should make the machine understand about this. So similarly, we'll check if y is greater than y max. Since the control is satisfied here, control will never go here. And since this is just if, so it will check, it will go here. It will just check what is x. X is 80, greater than 100, no. And since I have not satisfied here, I'll check here. What is x? X is 80, less than x. X mean no. So return code. What is code? Code is 8. So return this 8. Meaning x1, y1 is at top. Right. So this guy will now return 8, meaning it is now at the top. So outcode 0 is 4, outcode 1 is 8. That is, this is outcode 0. This is bottom 4, and outcode 1. This is at 8, means it is at the top. All right. So it's a do while. Now we will see what needs to be accepted, what needs to be rejected, and all these mathematics. All right. Now now the if loop says if outcode 0 or outcode 1. So means to say if not equal to outcode 0 is 4 or outcode 1, that is 8. So nothing, which is nothing but what is 4 or 8 is 0, 1, 0, 0 or with 8. This is 8, which is nothing but 1, 1, 0, 0. Right. So which is nothing but 12 in decimal. I mean, the 1100 is 12, which is nothing but true. Now what he says, not equal to true, means it is false. So it becomes something like this. It will now get calculated as if not equal to or true, which will now translate to false. So if false means the control will not go here. It will now come here. Now which says if outcode 0, that is 4, ampersand outcode 1, that is 8. So what is 4, 0, 1, 0, 0, ampersand with 8, that is 1,000,000. So if you add these two, you will definitely get 0, 0, 0, 0, which is equal to 0, which is equal to false. Now what he says, if false. So I will not go to this line, because it says else if this is false. Yeah, we got to know that this is false. If false, if true means I would have gone here. Because it is if false, control doesn't go here. It comes to this else part. Now here comes the Cohen Sutherland mathematics. So double x comma y. Okay. Now we know the slope. It is y1 minus y0 by x1 minus x0. Now what is outcode out? Okay. Now what he says, if this is true, outcode out will now hold outcode 0, else outcode 1. So what is outcode 0? Outcode 0 is 4. That is true. outcode 0. It translates something like this: is 4 question mark. Outcode 0 is 4 colon outcode 1 is 8. So what it says, if true, if that is true, select 4 or select 8. This is the conditional operator which you have studied in first or second semester PCD. So yeah, now outcode 0 is 4, which is true. So I will select outcode 0 and I will put this outcode 0 to outcode out. So your outcode out will now become outcode 0, that is 4. So outcode out is now 4. Now comes to this. If outcode out, that is 4 and top. What is top? Top is 8. So 4 and 8 means to say 0 1 0 0 ampersand 1 triple 0, which is equal to 0 0 0 0, which is equal to false. So if false, so I will not go inside. Next one, outcode out, that is 4 ampersand bottom. What is bottom? Bottom is 4. So outcode out 4 and bottom is 4, which is equal to 0 1 0 0 ampersand 0 1 0 0, which is equal to 0 1 0 0, which is equal to 2. Yeah. So 4 and 4 is 4 and it is true value. The control will now go to this part. But the real mathematics, the real fun starts here. You remember we did all this? All right. So if my outcode is at the bottom, means here. Yes. If my outcode is at the bottom, y is equal to y min, x is equal to this. Whatever we discussed a couple of minutes back, we will apply this form. Simple. So before that, it is what? X is equal to x naught plus 1 by m times y min minus y naught. That is 4. Yeah, this is 4. So outcode out is 4 equal to outcode 0. What is outcode 0? Outcode 0. This is 4. So is 4 equal to 4? Yes. Go inside. X naught is equal to x. So what is x? X is now 66. So this guy is 66. Y naught is equal to y. Y is now 50. So I am just earmarking my x naught comma y naught. Can you now tell me why am I writing or making xy as x naught y naught? What was my x naught y naught past tense? It was 60, 20. Right? It was 60, 20. Now what is x naught y naught? 66, 50. So I'm just earmarking that this is my first point now. This is my starting point now. It was starting point was 60, 20. Now the starting point is 66, 50. Now we'll again calculate outcode 0 because who knows, a single pixel can be outside. So we'll again calculate this. So we will now pass this 66, 50, 66, 50 as my x naught y naught. So it is now 66, 50. So code is 0. You will now understand that everything is 0, 0, 0. That is what I was talking about earlier. So what is y? Y is 50. 50 greater than y max 100. No. Else part I'll not check, but for your purpose I can write y is 50. 50 less than 50. No. X is 66. 66 greater than 100. No. Else part it will not check, but anyway we shall write 66 less than 50. Also no. So code, the control is neither going here, nor here, nor here, nor here. So control will now go here, return code. What is code? Code is 0. What is code is 0? Meaning your x, because you are passing x naught, y naught, the latest x naught, y naught. X naught, y naught is lying where? Code is equal to, see guys, 1 means left, 2 means right, 4 means bottom, 8 means top, but we got 0. What is the meaning of 0? Meaning of 0. Yeah, here. Meaning 0 means the pixel is inside the window. In fact, we had got this as bottom, now we got this as 0. So is lying inside the window. All right. So return this 0. Where will you collect? You will collect this to outcode 0. So my outcode 0 is now 0. Because complete outcode, it is returning me 0. Return code. So my outcode 0 is 0. Since I am done with if loop, I will not check else part. So you should keep on doing this as long as this guy is true. What he says now, he says not equal to, what is done? Done is, we didn't go inside this, we didn't go inside this. So done remains, it was false, it is still not equal to false, means it is not, not equal to false means, of course it is true. Not equal to true means false, not equal to false means true. So while true, yes, go inside the do loop. Now, what is outcode 0 now? Outcode 0, I have calculated this as my 0. So outcode 0 is 0. Outcode 1 remains same.
You can hear it now.
We didn't touch outcode 1. So 0, 0 or with 8. 0, 0 or with 8 means this is 8. This is true. Not equal to true means false. So if false means control will not go here, control will now come here. If outcode 0, that is 0 and 8. So this is 0 now, and 8 is equal to 0, is equal to 0, is equal to false. If false, so don't go here. Come inside. Double xy m. M will now again change. Why? Because x naught, y naught have been changed. You can see here. X naught is 66, y naught is 50. So we'll do that. Y1. What is Y1? X1, Y1 we didn't touch. X1, Y1 we didn't touch. We only touched X0, Y0. So 66, 50. So Y1 is remains same. Y0. That is 66, 50. So this guy will now become 50. And X1 remains same. X0. It was 60, it is now 66. So can you now tell me 120 minus 50, this is 70, 70 divided by 80 minus 16. It is 14. So 70 by 14, it is 5. All right. If now comes this, outcode out is equal to outcode 0. My outcode 0 is 0. So I will say outcode 0 is 0 question mark. It is outcode 0 is 0. Outcode 1 is 8. So now guys, look here. This is the interesting part. 0 question mark 0 colon 8 means if 0 is false, you can either, it says if false means don't take this value, take this value. Means if this is false, don't take this, take outcode 1. So the condition becomes like this. If 0, this you can take it as true case, this you can take it as false case. So since this is false, this you will not be taken, this will be taken. So outcode out will now be outcode 1. Outcode 1 is 8. 8 will now be given to outcode out. So outcode out will now become 8. What do you mean by outcode out is equal to 8 is we are now looking at the top region. That means we are now looking at this guy. All we did, all these mathematics, whatever we did, this happened for the first point, x0, y0. Now we have to do the same mathematics for x1, y. So the outcode, outcode is now 8. Now check. Outcode out is now 8. Is 8 ampersand top. Top is anyway 8. So outcode out 8 and 8, that is 100 ampersand 8. This is 100. This is now true. So 8 and 8, you will get 8, and that is true. So true and true, it is true. That means you are in the top region. Remember last point, x0, y0, we went inside this. Why? Because x0, y0 was at the bottom. Now x1, y1 is at the top. That is the reason we are going inside this. 8 and 8 is true. So go inside. So now comes the the mathematics. X is equal to x0. What is x0? 66. So 66 plus 1 by m. M is 5 times y max. What is y max? 100. Is 100 minus y0. Y0 is being changed here. It is 50. So so please calculate. So 1 by 5, 100 minus 50 is 50. 50 by 5 is 10 plus 66. It is 76. Right. So what is y max? Y max is 100. So it is 100. Okay. If you ask me what are these formulae, well, you remember this. Yeah. If you lie at the top, so y is equal to y max. That is what we did here. Y is equal to y max. And x is equal to x0 plus 1 by m times y max minus y0. This is what we did. X0 plus 1 by m times y max minus y naught. So this is my x. So this is my x. So 76, 100. Now what did we understand? X and y is 76, 100. The if loop has been satisfied here. I will not go to the cells. I will not go to the cells. I will not go to the cells. I will check whether here, what is outcode out? Outcode out. It is 8. 8 equal to outcode 0. Outcode 0 is 0. Right? Outcode 0 is 0. So 8 equal to 0. It is no. So control will not go here. Control will now come to this. Can you now understand what's the logic? Because if the control had gone here, that means I am done. I would have taken care of x naught, y naught. Since the control is now has gone to this part, it means I now should take care about x1, y1, which is nothing but this. This is x naught, y naught. This is x1, y1. We made this intersection point as x naught, y naught now, and we have x1, y1. The intersection point is 76, 100. We will now make that x1, y1 as 76, 100. Something like this. So x1 is x now. So what is x? What is x? Here. 76. Make that as x1. Y1 as my y. So y is 100. So make this as 100. So now we'll calculate whether we have perfectly calculated the outcode region of 76, 100. So we will now pass 76, 100. What it will return? It should return 0, because 0 means inside. 0 means it should return 0. We'll see whether it returns 0 or not. So I'll write this in a moment. So 76, 100. x1, y1, 76, 100. We will pass outcode out, compute outcode. So this is 76. This is 100. Now code is 0. Fine. Y is xy. This is 100. Is 100 greater than 100? No. I will not go to else, but anyway I will write here. Y is 100. 100 less than 50? No. X is 76. 76 greater than 100? No. Anyway, we'll write this loop as well. 76 less than 50? No. So control neither went here, nor here, nor here, nor here. Return code. Whatever is the code, code is 0. Return code. Code 0 meaning x1, y1 is lying inside the window. So return code, return 0. You can see the return type as integer. So it will now return 0, and that 0 will now be taken to outcode 1. So outcode, the final outcode 1 is now also 0. Now comes to these flower brackets. Now comes to this not equal to, as you remember, we didn't go inside this, we went here. So we didn't touch my done guys. So the done remains false. So not equal to false, true, while true. Yes, go inside the do loop. Now we will see the magic. Outcode 0. Both outcode 0 and outcode 1 are. Outcode 0 is also 0. Outcode 1 is also 0. So 0 or 0. Do 0 or 0. 0 or 0 is 0. 0 means false. If not equal to false. Not equal to false means true. So if not equal to false, if true means, what do you do? Accept, make it as true. Done, make it as true. So the moment done became true, this guy will now check. While done is true now, that means what? Not equal to true means false. The control will now come directly from this point, because this is a leaving situation where we should leave here as long as done is false. Now that done became true, I will directly come to this point. Now except is also true now in our case, because we went here, except is true, done is true. So done became true, we came out of the loop, and except is also true. So now go here, if except, that means if true, except became true. And this is, anyway, I have taught you in the 2D viewing class. These are my scaling factors, means to say this, the zoom to that scaling one. I taught you in the class what is positive scaling, negative scaling. Positive scaling means the same shape getting increased. Negative scaling means the same shape getting reduced. Now since we are having positive, so we will take positive scaling factors. This I have taught you in my theory class, just to give you an idea. You remember this. Yeah. So yeah, if you remember all this, whatever we did this big derivation, right? So all this derivation and the problem. So yeah, go back to that. This problem, xv is equal to xv min plus this into sx, and that is what this sx stands for. So yeah, here. I'm saying this sx is equal to xv max minus xv min by xw max minus xw min. So that is what he says. And sy is yv max minus y minus, sorry, this is yv min. Yeah, this should be y, sorry, w max minus yw. That is what this guy says. And vx, my viewports. So do the same mathematics, you will get this. So apparently in fifth program, this, whatever derivation we did, all this, these are the equations here. All right. So write those equations. We can calculate. I request rather you guys to calculate. I'll show one guy. Sx. What is xv max? Xv max is 300. So we'll write. Please open up your calculator. So it is 300 minus xv min. It is 200. 300 minus 200 divided by x max minus x min. So what is x max? X max, not xv max. X max is 100. X min is 50. So 100 minus 50, which is equal to 100 by 50. It is 2. This is 100 by 50. All right. Each guy gets 2 rupees. Similarly, do for sy, vx0, vy0, vx1, vy1. You will get these guys. See, this is your window. This is your view window. This is x min, x max, y min, y max. This is your x vx0. Vx0 is this guy. Vy0. This is vx1, vy. Calculate these. You will get the zoomed version of this. That means you have the 66, 50 and 76, 100. The zoomed version of 66, 50 can be something like 86, 60 or whatever. The zoomed version of 76, 100 can be something like 96, 120, whatever. So those values you will get for these guys. Vx0, Vy0. I'll tell you what do you mean by Vx0. See, x0, y0 is your input. Vx0, Vy0 is this output's first angle, first coordinate. X1, Y1 is your input here, and Vx1, Vy1 is your viewport X1, Y1. So once you get Vx0, Vy0 and Vx1, Vy1, mind you, Vx0 formula, in that formula you should apply this Sx, the calculated one, and Vy0, Vx1, Vy1. So what I ultimately want is Vx0, Vy0, Vx1, Vy1. So once I am done with that, and now my job is very simple. I'll draw one line loop, one rectangle. Now rectangle has 4 points. I'll write that xvmin, yvmin, xvmax, yvmin, I mean all these points. So I'll get this big rectangle. Now I should draw from Vx0, Vy0 to Vx1, Vy1. So draw the line Vx0, Vy1, Vy0, Vx1, Vy1. End it. So once you're done with the entire Cohen Sutherland, you come back to this and you flush it. Now this essentially ends the discussion, but we will close the loop by keeping last 5 minutes discussion by keeping breakpoint. So what we will do is so where we started the line, display, this is the input. In Cohen Sutherland we will go and yeah, this is cut. Now what we will do is first I'll show you this way. First I'll keep the breakpoint here, and let me close all this. All right, so blood display, font of display. I'll come to display. I'll breakpoint is here. So debug it. Compiler is in use. Yeah. So display, yeah, we'll keep it. The flush, debug it. So it will now go to the debugging mode, and I kept my watch. X0, Y0, X1, Y1, all those. So the yellow triangle is here. That means to say the control is here. So what we will do is we'll say next line. So I got this line now. So we'll now click next line. Flush it. We'll get a flipping rectangle. Now don't press next line. You should apparently go to Cohen Sutherland function. So press step into. So yeah, step into. You can see all my regions. So now you can say next line, all this. It will now calculate all those whatever we did. So yeah, ultimately it comes, calculates all my output zeros, whatever we did, whatever we tried to do manually. And yeah, and then it became done. So SX naught, now I can press next line. SX naught, SV naught, VX naught, yeah. Line loop, I'll get a maximized rectangle, correct? So now my job is to give me a nice line, something like this. So that's it. That's it about today's session. I hope you really enjoyed it. I will, of course, the recorded video I'll post to YouTube. Let me know how the session went in my YouTube comments, and any doubts, please post there itself. Thank you. Thanks for your time. Thank you.